parallel to DC. Ne? And then from this width, comma, width what? With angle A being equals to what? Being equals to angle D being also equals to 70 degrees. So you can actually see this is also there on the diagram that our angle A is 70 degrees as well as angle D is 70 degrees. Ne? And the EC and EC and EC, or the length of EC, is equals to the length of DC. It's equals to the length of DC. So one thing that you must actually know is that at times they will give you the information, but when you look at it on the diagram, they are not equal. So as long as they are telling you that EC is equals to DC, you must show it on the diagram. But in this case, they actually showed us that these two sides are equal in length. Ne? And then they're saying what? Prove that ABCE is a parallelogram. Prove that ABCE prove that ABCE is a parallelogram. It's a parallelogram. Parallelogram. So one thing that you need to understand, I actually showed you on one of the videos on how do you prove that that is a parallelogram. But on that video, I actually showed you the construction part of us drawing diagonal line, AC or BD. So in this case, for us to prove that ABCE, it's a parallelogram, we are not going to draw a diagonal line, because the reason why there on the proof, I actually draw the diagonal line that serves as a construction. I actually wanted you to get to know the angles which are equal. But as you can look at this diagram, since they're telling us that in the trapezium ABCD, since ABCD is a trapezium, we are having those angles which are actually elaborated. Hence, there's no need of us drawing what? Drawing this a parallelogram. But for us to be able to prove this statement, that serves to say ABCE is a parallelogram, you'll actually use one of those proofs that I actually showed you on the previous video. So we know that this is how basically we're going to prove a parallelogram. So the first thing that I'm going to do, what? You know what, from here, the length of EC, is equals to,
Sir,
yes, Milentle?
I have a question.
Yes.
Where like you wrote in trapezium ABCD, comma AD is parallel to DC. Is it AD or AB?
It's AD, it's parallel to BC. AD is parallel to BC. BC.
Okay.
Thanks, B. Should I was writing, but I palanga, thanks, Milentle. So as I was saying here, you're gonna say EC. We know that here, EC is equals to CD. It's given. This one is given. And one thing that you must actually know is that in Euclidean geometry, each and every statement should be accompanied by the reason. It's actually given. Ne? And then from that statement, I will just write that angle E2. Look at angle E2. Angle E2 is equals to angle D. So that will be opposite sides equals opposite angles. So here it will be opposite sides equals opposite angles. So myself, long back, more than, I don't know how many years, that's more than 13 years ago while I was doing grade 10. So while I was doing grade 10, they were allowing us to write base angles of an isosceles triangle. That serves as part of our reason, because from this green triangle, ECD, when you look at triangle ECD, look at it. The two sides are actually equal. So the two sides which are equal, that is the length of EC, which is equals to the length of CD. Ne? And then with regards to that, when EC is equals to CD, it means to say we know what that will be an isosceles triangle. And then what happens with the information that has to do with isosceles triangle, base angles of an isosceles triangle are equal, which is E2 is equals to D. So here, they were allowing us not to write opposite sides equals opposite angles. We were actually writing base angles of an isosceles triangle are equal. But for you guys, I will prefer to write what? I will prefer you to write opposite sides equals opposite angles. You know why I'm saying that? It's because of, it's not every student who can be able to see that triangle ECD is an isosceles triangle, because they didn't tell you to say it's an isosceles triangle. But based on how we teach, it's a must that it should be an isosceles triangle, because one of the properties of an isosceles triangle, it says that base angles of an isosceles triangle are equal. So if you guys an isosceles triangle are equal, some of the teachers, they can actually do what? They can actually penalize you. But long back while I was at school doing grade 10, myself, they were allowing us. So just because of it's not every student who can be able to say that triangle ECD is an isosceles triangle, the only reason that they will actually mark correct is you writing opposite sides equals opposite angles, because they know that when you are saying opposite sides equals opposite angles, that comes as a result of you knowing that angle E2 is equals to angle D. So here you can actually conclude and say, therefore, the size of angle E2, that will be equals to, so from the given information or from the diagram, you can actually see that angle D is given as 70 degrees. So that's going to be 70 degrees. You're going to write 70 degrees. So that's the first starting point. E2 is equals to 70 degrees. And then with regards to that, let me now make my diagram to be much nice so that you can be able to see. So look at this. So these are parallel lines. And then we are having a Z. That Z, I'm going to draw it using a green card. Look at that. So one thing that you must remember is not to say when I'm showing these parallel lines here, I'm only saying AE is parallel to BC. No, that's not how we interpret it. As long as you're having parallel lines, it simply means to say the whole entire line, which is AD, is going to be parallel to the whole entire line, which is BC. So you must know it by that. And then after knowing that, since now you understand the concept of alternating angles, remember, for you, if you don't understand I'm alternating angles, you'll just use the information that I'm actually showing you now. So I once wrote a term called fantox, if you still remember, to those who started with me long back ago while I was teaching you. But for the sake of the likes of Naldo and the rest of the crew who just joined now, I'm gonna write this fantox term so that you can remember or know based on what does it mean. So this term fantox, it has some reasons where you did in geometry. So if you can remember the term fantox, whenever you deal with Euclidean geometry, just remember to say, hey, Sir taught me this term called fantox. And then how does this term work? See, point the rest of the crew. We know that here we are going to have parallel lines. So this fantox, it's a 6-letter digit. The first 3 letters, they have parallel lines. The last 3 letters, it doesn't have parallel lines. So the first 3 letters have parallel lines. So it means to say fan, it's going to have parallel lines. It's a must that first 3 letters, they have parallel lines. And then the last 3 letters, it doesn't have parallel lines. And then since now you understand that, oh, I've taught you fantox, what is the reasons behind this term fantox? So the first F, you know that this angle is going to be equals to that one. The reason it will be corresponding angles are equal. And then if here I'm having, let me put X and Y here. On the second letter U, you know that if you add X plus Y, it's going to be equals to 180 degrees. What's going to be the reason? Co-interior angles are supplementary. So when I talk about co-interior angles are supplementary, it means to say when I add X and Y, I must get 180 degrees. You know why? It's because of in maths, In math, supplementary angles, it means to say they add up to 180 degrees, but complementary angles, they add up to 90 degrees. So it's a term Van Tox. First F, you know that, oh, this angle is equal to this one, corresponding angles. The second letter U, if you add X plus Y, you must get 180. That's going to be called interior angle supplementary, because supplementary angles, these are angles that add up to 180 degrees. And then the one that I want us to concentrate on is this one here. We know that this angle is going to be this angle. It's going to be equal to that angle. That will be alternating angles equal. Actually, I was supposed to write fast talks, but it wouldn't make sense to most of you if I'm going to say fast talks. That's why we normally consider this letter as N to say fun talks. If it's going to be fast talks, it means to say this letter, it will actually change to be like that. Though you'll know that this angle is equal to that one. Then hence it takes you back to what basically we are having on that green letter on that diagram. So you need to understand to say, now when you deal with Euclidean geometry for grade 10, you must know our theorems that I taught you, the first theorem as well as the second theorem. Don't worry, I'm going to still repeat them for the sake of those ones who recently joined us. And then also you must know our properties of our triangles. We know that we are having different types of triangles, be it an isosceles triangle, be it an scalene, be it an equilateral triangle, be it a right angle triangle. Also, you must know our properties of parallel lines, of which the properties of parallel lines is the one that actually led me into drawing this term called fun talks. So it was supposed to be fast talks, but it didn't make sense for me to say fast talks. So hence I'm going to say fun talks, right? So I'm going to come with that. So to those who are joining us for the first time, you know that now I've taught you the 6-letter digits, which is fun talks. First 3 letters is the only ones which are having our parallel lines. Last 3 letters, it doesn't have our parallel lines. Let me repeat myself. The first letter, corresponding angles are equal. The second letter, X plus Y is equals to 180. Co-interior angles are supplementary, because supplementary angles, these are angles that add up to 180 degrees. And then the third letter, this angle is equals to this one. That will be alternating angles equal. And then this T, you now know that, oh, this T, it means adjacent angles on a straight line. To add what? To 180 degrees. Oh, this is O. Oh, this O, it means angles around the point. It means to say its angle of revolution is 360 degrees. And then the last X, it simply means to say when 2 straight lines intersect, the vertically opposite angles are going to be equal. This angle is going to be equal to that one. That will be vertical opposite angles being your reason, as well as this angle right here. It's going to be equals to this angle right here. That will be vertical opposite angles are equal. So it means to say, whenever I'm teaching you Euclidean geometry, you must make sure that you write notes, must make sure that you ask where you don't understand. And then in a case whereby we are giving our parallel lines, like when you look at that, let's go back to our diagram. Look at that. So I was not supposed to write fun talks, but the reason I'm writing it, I want you to be able to see, to say, if I'm going to say E2 is equals to C1, you must not be confused. Why am I saying that? It's because of we'll be taking it from the diagram that green Z, it means to say it's alternating angles from this term fun talks. So it means to say if you can understand these terms that I'm teaching, then there's no way you can struggle with Euclidean geometry. So we know that, oh, here, as part of us continuing, I will now continue and say what? Since now you understand fun talks, I will now continue and say E2, angle E2, it equals to what? It equals to angle C1. Why am I saying E2 is equals to C1? Look at this. Let me show you for the sake of those who don't see. That's E2. It's going to be equals to C1. It's alternating angles equal. Where am I taking it? I'm taking it from the term fun talks. Do you all see? And then with regards to that, now since you understand to say, oh, I've now taught you fun talks. Yo. Hello guys, can you hear me? Can you hear me, guys? Now those people, can you hear me?
Yes, sir.
Sure, I experienced a network glitch there. Ish. My network just went out just like that. Ish. Yeah. Ne? Yo, okay, let me just redraw the diagram. Imagine as I was teaching and I wrote a lot of information, it decided to go out. Shiane, the devil is fighting us, but we are more than conquerors. So let's continue. So I drew something like this, and then I'm just gonna write angle A here. I'm just gonna write angle B. But so far, do you understand, all of you? Angle C. Then that's angle D. Do you understand, Ronaldo? Do you understand C? Where are the rest of the guys? So this is E1, E2. Then we now know that this side is close to that one. And then here we're having C1 and C2. And then from here, remember here they gave us what, 70 degrees. This network thing disturbed me. Look at now I'm rewriting this. Then also we had my parallel lines here. These two lines are parallel to each other. So but you will actually continue from what I was teaching. So here, remember, I made this. I made this to say this. Somewhere, somehow, as we were proving, we ended up saying E2, it's equals to what? That's going to be equals to angle C1. So that will be alternating angles equal. So this one, you'll just write alternating angles equal. So that will be alternating angles equal. And remember, I said what? If you check E2 on our previous proof, we got it. E2, we got what? We got 70 degrees, if you still remember. We got 70 degrees. And then I said it's going to be opposite sides equals opposite angles, if you still remember. Opposite sides equals opposite angles. Opposite angles. Ne? So now I'm showing you the very important part. So after this, and don't forget that here on the diagram, there is 70 degrees. Our angle A is 70 degrees. Make sure that you put it. So from this, you can actually see, or you know that angle A is close to 70 degrees. So this angle A is close to 70 degrees. You don't calculate it. It's actually given. And don't forget that each and every statement in Euclidean geometry, it's accompanied by a reason. And from here, you're basically gonna look at these two angles. So actually, you can also conclude to say, since E2 is close to C1, you can now conclude and say, therefore, what's going to happen between the two angles? You can conclude to say angle A is equals to angle what? It's close to angle C1. Why am I saying angle A is close to C1? Because when you look at A, it's 70 degrees sharp. When you look at C1, it's equals to E2, of which E2 is equals to 70 degrees. That's why I'm concluding to say you're going to have angle A is equals to C1 there. And then apart from that, let me show you something. Apart from this, let's continue because it's very important. It's very key for me to write this information for you guys. So now let's calculate angle E1. So angle E1, you go back to Van Toks again. Angle E1, it's adjacent angles on a straight line. I'm going to add E1 plus E2. We welcome you, Tiro. I'm going to add E1 and E2. So when you add E1 and E2, who can tell me what are you going to get? When I'm adding E1 and E2, angle E1 plus angle E2, these two angles, they will give me how much? Who can tell me? Let's add angle E1 and E2. Those are sum of angles in a straight line. So sum of angles on a straight line, we know that we are getting
Sir,
180 degrees. Yes, Minent?
I leave it. I was gonna say it.
Oh, okay, sure. So remember, after that, you write each and every statement should be accompanied by the reason. So it will be angles on a straight line. Angles on straight line. Straight line. Ne? Angles on a straight line. Then after that, you go back. Now we know that we want to calculate angle what? Angle E1. So it means to say I'm gonna write angle E1 plus our angle E2. There you go. It's how much? It's 70. So Naldo, it's 70. It's equals to 180 degrees, guys. So one thing that you need to understand, from here, you are calculating angle E1. Angle E1 is gonna be equals to, then you write 180 degrees. And then you take,
70.
yes, it's gonna be minus 70. Do you know why? Tiro, is it minus 70? It's because of when you take positive 70, transposing it on the other side, it changes the sign to become negative. And then that will be angle E1. It's equals to, then let's subtract 180 minus 70. What do you get? Is it 110? What do you get, guys? Yes. It's 100, 110. It's 110. Ne? And then, remember, the question wants us to prove that ABC it's a parallelogram. I'm still showing you how to prove it. So, after getting that, you know good, oh, my angle E1, it's 110 degrees. Ne? And then, there are two ways in which you can calculate angle B. This angle right here, there are two ways in which you can calculate it, this one. Remember again, let me show you this hint again. Look at this. Which color can I use now? Look at the red part. So when you look at the red part, look at it. Look at the red part. From fun talks that I was actually explaining, you are having a parallel line. So we'll add angle A plus angle B. It must give you 180 degrees because those are co-interior angles are supplementary. So from fun talks that I actually showed you now, you'll just say but. You'll just say but. What happens? But angle A plus angle B from the fun talks that I taught you, it's equals to 180 degrees. Remember, each and every statement should be accompanied by the reason in Euclidean geometry. So why am I saying A plus B is equals to 180? It's because of co-interior angles are supplementary. So here you'll just write co-interior angles supplementary. Supplementary. Co-interior angles supplementary. So when you speak about supplementary angles, it means to say they add up to 180 degrees. And then what's going to happen? You go to the diagram. So our angle A, we know that we are given 70 degrees. So this basically means to say you substitute and say 70 degrees. And then you say plus. Now you solve for B. Angle B, it's equals to 180 degrees. Then when you arrive here, it's a matter of you now solving angle B. So how do we solve angle B? You're going to say angle B, it's equals to what? 180 degrees. And then that will be minus 70 degrees. So what is 180 minus 70? That should be what? That's 110. Angish?
Still 110.
Yes. Since
Yes.
it's still 110, you can actually see that angle E1, Minentle and the rest of the crew, E1, we got 110. E2, we got 110. Remember, I showed you one of the theorems to say opposite what? If you still go back to one of the theorems that I actually taught you, I actually proved a theorem for you. I think that was theorem number 1. What does theorem number 1? Yo, guys, my network, yeah, it's very, very bad. My network is very, 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 very bad. I don't know. My network is very, 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 very bad. So let's try for the last time. But going onwards, I will appreciate if we don't connect late, because if we're connecting late, we're gonna be disturbed by network. That's why I wanted our session to be at 4 o'clock, because now everyone is using the network, so hence it's too slow. So going onwards, I would appreciate if you connect earlier. Ne? So let me just try to go back from the theorem that I wanted us to prove. So when you look at this question, it's a pity that my diagram got erased. Okay, let me just try to rewrite it. So I prefer our sessions to be a bit earlier, because if it's late, the network, it's always going to be a problem. Though I'm using unlimited, it's always going to be a problem. So this, we are given as A, B, C, D, and E. So what I'm going to do, ne? I'm going to try to make sure that, because we got disturbed a lot on this session, I'm going to try to make sure that I do, because there are recordings that I need to send all of you. That's why I said you must send your emails. So what I will do, I will actually record this video from scratch to show you in a video format, so that you go through it, because I'm not happy on how the network did to us, because most of you won't understand it based on how I was teaching it, because we got disturbed by network. But what I wanted you to know is that if they say prove that ABCE is a parallelogram, you'll go back to the notes that I actually said you must write. Ne? So before the network, we got disturbed. The last step, I wrote E1, we got 110 degrees if you saw it. And then I also calculated angle B, it's equals to 110 degrees. Don't worry, what I'm gonna do, I'm gonna redo this session, send you on your emails today. After this session, I'm gonna repeat this session, and then so that you can be able to see step by step, because now everything is haphazardly so, because some information got erased while I was teaching. So we got angle E1 being 110, we got angle B being 110. Ne? So since E1 is equals to 110, since B is equals to 110, it means to say you'll now conclude and say, therefore, angle E is equals to angle B. Because why are we saying angle E is equals to angle B? It's because of both of these angles they're equals to 110. And it's E1, so to say, key E1. Remember on the diagram, we had E1 here, we also had E2 here. That's gonna be E2. I'm gonna redo this session smoothly, nicely, so that you can be able to see. So now we got this angle E1 is equals to B, which is E1 is equals to B. So those two angles, if E1 is equals to B, then now we can conclude to say ABC is a parallelogram. So it takes into consideration of all the notes that I told you on yesterday's session. But one of those notes that I wrote on yesterday's session, they're very important. They will actually help you to prove this. Then you now conclude and say, therefore, what? ABCE, ABCE, ABCE. Don't stress, guys. I'm going to redo this so that you write it properly, because an issue, we got disturbed. ABC is a parallelogram, but it's not difficult. The way I teach, my math is very easy. It's just that now we got disturbed by network. Parallelogram. And someone can actually know this before I even proved it, because yesterday I actually gave you insights, and I also gave you tips. I also gave you a lot of notes on how to prove that a quadrilateral is a parallelogram. So it basically means to say, you're going to take the information that we had on yesterday's session. To those who were not here on yesterday's session, the good part about myself is that I record all the sessions. So I'm going to send you all those videos on your emails, so that you can be able to recap and make notes for yourself if maybe this is your first time joining, because I realize that there are also some people who joined us.